Hey Aldershot iSTEM, welcome to your first math distance learning lesson. We're going to try it like this and see how it goes. I've made a recording of my lesson that you're going to be able to watch. I found a cool app. It's a whiteboard app that'll let me kind of talk and write virtually at the same time. And we're going to go through this and hopefully learn something. If you could grab a piece of paper and something to write with, you could write things down as I go, kind of make a summary. The nice thing about this being a video is that you can pause anytime something I say isn't quite clear and we kind of rewind it and go back and see what you need. So we're learning today about something called distance time graphs. Distance time graphs is a natural extension to what we were doing before March break, which was lines and lines of best fit and slope. We were playing around with slope. So this will be a nice ease in for us. I'm going to tell you a little story about something I did the other day, and I'm going to turn it into a graph. And you can hopefully make sure you understand as I go. So last Friday I was at home and I was able to, for the first time, get into Aldershot School to pick up some teaching supplies. So I started at my house. Aldershot School is about 40 kilometers away from my house, and it takes me about 30 minutes to drive that far. So in 30 minutes, I was able to drive 40 kilometers an hour. I'm going to connect those 2 points with a nice straight line. That's the point 30 minutes and 40 kilometers. So my x-axis here is my time axis, and my y-axis is my distance, my kilometers. So I get to Aldershot after a 30-minute drive, and I sit at Aldershot and I can go into the school and I can collect my supplies. We're only allowed to be in there for 15 minutes. So during that time, my distance away from home doesn't change that much. In fact, it doesn't really change at all. It's a nice flat horizontal line. After that, I had to go to Costco. I had to pick up some groceries from Costco, and there's a Burlington Costco just around the corner. It's about 10 kilometers away. It takes me about 15 minutes to get there. So after leaving Aldershot, I drive for another 15 minutes, and I am now 50 kilometers away from home. So after 1 hour from leaving my house, I am now 50 kilometers away from my house. Costco was busy, and even though I had a nice list, it took me a while to figure out and find everything I needed and get checked out. So I was at Costco for about 30 minutes. So 90 minutes after that, I'm still 50 kilometers away from home. But good news, after I was able to leave Costco, I could drive straight home, and traffic was really light heading back to my house. So it only took me 30 minutes to get home from Costco. So there's my drive represented. I'll call this area region 1. My drive from my house to Aldershot. Region 2 would be me at Aldershot picking up my supplies. 3 is me driving from Aldershot to Costco. 4 would be me shopping at Costco. And then lastly, 5 is me driving home. So think about what we know about slope. We know that slope, which we call m in our equation y equals mx plus b, is the rise of a function or a graph divided by the run. So using that formula, I can figure out my average speed between 2 points on this graph. So I can look at these, say, 2 points from when I left Aldershot School to when I got to Costco, and I can figure out how fast I was driving. So I'm going to find the slope between those 2 points, and I'm going to start by finding the difference in the y values. That'll give me the rise. 50 minus 40. Okay, Costco's 50 kilometers from my house. Aldershot was 40. What's the difference? And then I can find the run by finding the difference in my x values. 60 minus, and this is tricky here, this is 45 minutes. So 60 minus 45, and I get 10 over 15. If I divide that on my calculator, 10 over 15 is 0.66666 forever. Well, that doesn't make much sense to me. That is 0.66 of a kilometer per minute. We don't really talk about speed that way. So how can we convert that into a measurement that we can kind of think about a little bit easier? If I'm traveling at 0.666 kilometers per minute, and that's 10 over 15 kilometers per minute, well, I can multiply that by 60 minutes in 1 hour. I can do some canceling. I know that 15 goes into 60 4 times. 10 times 4 is 40. So my drive to Costco, I averaged a speed of 40 kilometers per hour. Okay, so I can take a story, I can change it into these distance time graphs, and then I can use my understanding of slope to find how fast I'm going at different parts of the graph. Thinking about slope as rise divided by run is a good introduction to how we think about slope. I'm not always going to have situations where I have graphs that go through points on my grid in such a nice way that I can read the data directly from the graph. Sometimes I got to maybe estimate, and that's not always the best way to do it. So if I have a line that has 2 points on it, maybe I'm told those points. It could be anything really. I can use those 2 points and I can imagine finding the rise and the run between those 2 completely random points on this line. The rise and the run, not easy to draw a straight line, by finding the difference between these 2 points. So I can find the difference between the y values to find the rise. I could find the difference between the x values to find the run. And that lets me create a different version of the slope formula. I'm going to find the difference in the y values, y2 minus y1. And I'm going to divide that by the difference in the x values, x2 minus x1. And if I can do that and simplify, I will find my slope. So think about the last question we did. y2 was 50. y1 was 40. x2 was 60. x1 was 45. So we did this already, and we still get the same kind of answer, 10 over 15. Okay, so a couple big ideas from this video: taking a story and turning it into a distance time graph, using the slope formula, rise divided by run, but making it a little bit more sophisticated, finding the difference between the x values, the difference between the y values to help us find slope when the points aren't always easy to read. Okay, take that information. I'm going to give you a Desmos activity to try, use that information, and use the Desmos activity, try and answer a few more questions. Okay, good job.